Hello, everyone. Welcome to the Math Magician's Den. We're here again to talk about limits. And again, we're going to do limits from a graph. We're going to do limits from a table. And then we're going to try limits algebraically. But the type of function we're going to do this time is we're going to take the limit as x approaches 0 of x over radical x plus 4 minus 2. Now, what happens here when I plug in 0? When I plug in 0, okay, guys, it's going to give me 0 over radical 0 plus 4 minus 2. Well, that comes out to be 0 over 0. That, ladies and gentlemen, is an indeterminate form. An indeterminate form basically means that you cannot find the limit the way it's written. It doesn't mean you can't find the limit. It just means you can't find the limit the way it's written. So what we're going to do here now is we're going to take two limits. We're going to take the limit as x approaches 0 from the left of this function x over radical x plus 4 minus 2. And we're also going to take the limit as x approaches 0 from the right-hand side of the same function. Now, the green one is called a right-hand limit, RHL for right-hand limit. The red one here is called a left-hand limit, LHL. And what we're going to do is we're going to look at the graph. So what I did was I punched this function into Desmos, and we got a graph. Now, when you look at this graph, as you approach 0, there's going to be a hole right there. And why is it a hole? Because as you approach 0, or if you plug in 0, you're going to get nothing. Now, what happens as I approach 0 from the left? Now, notice these x values are less than 0, but I'm getting closer and closer to 0 from the left-hand side. Take a look at those y values. What does it look like those y values are approaching? It looks like to me they're approaching 4. So if I go back here and I want to put in the left-hand limit, it seems to me like those values are approaching 4 from the left-hand side. We're going to do the same thing on the right-hand side. We're going to get close to 0 from the right-hand side. Notice my x values are getting closer and closer to 0 from the right, but those y values are approaching what? It looks to me like they're getting closer and closer and closer to 4. So even back here on this screen, I'm going to say the right-hand limit is 4. Now, if both of those are the same, if the left-hand limit actually equals the right-hand limit, then what I can say, the two-sided limit, the limit is x approaches 0 of x over radical x plus 4 minus 2. Well, this has to be 4. And that's how you can find the limit from a graph. Now, we're going to do the same thing looking at a table. Now, what's great about Desmos here, you can plug in a function, and in this table, I've actually got c equals 0, and it's automatically plugging in the values for f of x. And you can actually do this on your graphing calculator as well. So c equals 0. Now, this one's even better than I've seen some other problems. If you take 0 minus 0.1, look how close this is to 4 already. If you're 1/100th of a unit away to the left, 3.997, even closer to 4. If you're 1/1000th away to the left, 3.99975. You can tell these numbers as you get closer and closer to 0, those y values are approaching 4. That's the left-hand limit. Now look at it from the right. This is 0 plus 0.1. And if I zoom in on this graph, you guys can actually see these numbers. Here's the three numbers from the left. There we go. 0.1, negative 0.01, negative 0.001. They get closer and closer and closer to 4. Take a look at the numbers from the right-hand side. Close to 4, even closer to 4, really close to 4. So it seems like the limit from the right-hand side is also approaching 4. Okay, so the limit from the table and from the graph seem to indicate this limit approaches 4. Now we're going to do something else here. We're going to do this algebraically. And we're going to use a method that's called rationalization. Rationalization basically is what you do when you're working with limits and you see radicals. And this could be radicals on the top or the bottom. And what we're going to do, whether the radical is on the top or the bottom, we're going to multiply by something we call the conjugate. If this one has radical x plus 4 minus 2, so what I'm going to do top and bottom is I'm just going to change that middle sign and make it radical x plus 4 plus 2. That's what I'm going to multiply on the top and the bottom. That red writing there, that is a fraction that equals 1, so I'm not changing the value at all. But what this does, it's going to change the look. This is the limit as x approaches 0. Now on the top, we're not going to multiply this out. And you'll see there's a reason I am not going to multiply this out on the top. The only thing I'm going to do is I'm going to multiply the conjugates. Now when you multiply conjugates, here's what happens. If you take a minus b times a plus b, the result should be a squared minus b squared. That's what happens when you multiply conjugates. So if we take the first term times the first term, I'm going to get x plus 4. If I take the last term times the last term, I'm going to get minus 4. I don't have to multiply the outer terms and the inner terms because they're going to cancel out. Now, if you take a look at this problem here, those 4s are going to cancel, and what it leaves me with, I've got a limit where I've got x times radical x plus 4 minus 2, but on the bottom I've got x. And we've discussed this in the past, in previous lessons, units. Those x's cancel. That, ladies and gentlemen, is the 0 over 0. Now that I've canceled out the 0 over 0, I should be able to try this limit again. Plug in 0. I would get radical 0 plus 4 minus 2. And if you do that calculation, what's the limit? I'm sorry, I need a plus 2 here. Need a plus 2 here. This is going to come out to be 2 plus 2, which is 4, which is what we said the limit was in the first place. So make sure that you can do limits from a table, make sure that you can find limits from a graph, and also make sure that you can find limits from a function algebraically, in this case using rationalization. If you enjoyed this video, hit the like button. Also, I would appreciate it if you subscribe to my channel. I'll post more videos soon.